In this video, I'm going to be showing you how to build out a natural language map application that leverages GPT-4, a Leaflet, and Next.js. So how this application will work is we'll be able to submit a query, something like, where is that iconic bridge in SF? And what it will do is we'll get a coordinate from GPT-4 as well as a title from the query that we submit. So if I say, what is a fancy area in Vancouver? You'll see that relatively quickly we get a response back from GPT-4, and then based on the coordinates, we're going to get the pin here with our title rendered in the top right-hand corner here. So you can say things like, what is that famous building in Toronto? Or something like, what is that famous bridge in NYC? So you can see it's relatively quick, and it does have a neat fly to effect that is built into the Leaflet library that makes this sort of fun to play around with. So the way that we're going to set this up is I'm going to run through what you need to do to set up your initial boilerplate. Then I'm going to run through the front end and back end, which is actually not that much code. I'm going to run through it within hopefully 15 minutes here. And then by the end of it, you'll have a working example of this. So you can also pull down the GitHub repository if you'd like to do that. Otherwise, if you'd like to follow along and see what everything is doing step by step, feel free to stay tuned. So the first thing that I'm going to have you do is you're just going to have to create a new Next app. So if you haven't done that before, you can simply run within your terminal npx create next app at latest, and then you'll get a number of questions that you'll just have to answer. So we're going to be using TypeScript, so make sure to answer yes for this. We're going to be using Tailwind, and we are going to be using App Router. So once you have that all set up, I'll just pull over the VS Code here. Now, what we're going to have to do is we're going to have to set up a .env here. And once you have your .env, head over to platform.openai.com/account/ let me get this right, /API keys, and simply make a new API key. Then once you have that API key, you can go within your .env and then type this just as you see. So OpenAI _API _key, then paste in your key there. Then you can go ahead and close out your .env. So we're going to make a simple tweak to our page.tsx. So this should be here from when you made the create next app. And what we're going to do is we're going to have a dynamic map component here. So we're just going to import dynamic from next dynamic, and then we're going to import the component here, and we're just going to have that one component within the page. So once we have all that set up, I'm going to run through our backend first, then our front end. So our backend is going to be pretty short, pretty straightforward, and we just have a couple dependencies for this. Now, as I go through, you will see that there are a few dependencies that you will have to install. So like OpenAI and .env. So just make sure that you npm install those, or bun install, or whatever you're using as your package manager. So in this, just go ahead and install those and then import them like you see here. So we're going to have OpenAI to interact with the GPT-4 model, and then .env simply to reach into our secret key there. Now, the nice thing with the new version 4 of the OpenAI Node SDK is you don't actually need to pass in your API key. So you don't need to put in an object that's like API key process.env, etc. You can just instantiate it just like you see here, and it will assume the OpenAI _API _key if nothing is passed in. So from there, we're simply going to set up our endpoint. So we're going to wrap it in a try catch. Then we're going to have a chat completion here. So I just named this GPT-4 completion. We're going to specify that we are using GPT-4, and then this role here, this is the important part to make our payload that we get back more reliable. So the system message, this is how you specify it here. So role system, and this is essentially what's telling the GPT-4 model every time its role. So I'm saying you only return JSON, a coordinates key with a value in this format, then a title of the location with a title key. So this could probably be even more improved, but I found this alone does work pretty well in my testing of the app. So next, we're going to specify the role of user for the next message in our array, and we're going to simply pass in the message that we have on the front end of our application. So like the what is that famous bridge, that's what we're going to be passing in here. And just pause here for a moment. So the one thing with this application which is nice is even though we are using GPT-4, because their models are based on tokens, you can see here that a query like this or an application like this in general is you're not going to be putting in like a large body of text into this, generally speaking, right? So you'll have simple queries, a few words like this, like you saw in my demonstration. And then the nice thing with this is both what we're sending and what we're receiving are very short, succinct responses and queries. So in terms of the cost, even though we are using the latest and greatest GPT-4 model, we aren't actually sending a lot back and forth. So just something to sort of keep in mind. So then we're going to extract the contents of the chat completion, and we're just going to do a very simple check to see if it's indicating that it does have a JSON payload. So we're just going to check the first character of the payload that comes back, and if it has come back with that curly brace as a first character, we're going to go ahead and parse that response and then send that response and log it here. So we're going to send the response to the front end, and then when we go through the front end, you'll see how we use those two pieces to render out what we had here. So, and then we're going to send back a try again. So if you put in gibberish here, I have it set up so it's going to just send you somewhere in the ocean and it's going to say, please try again. That's essentially the flag to do that. And then we're also just going to be handling out the errors. And that's it for our endpoint. So less than 40 lines of code with comments to set up all that we need to be able to get everything from the GPT-4 model to make this application work. So next, we're going to be setting up a map component. And what I don't think I mentioned is just make sure that you set up these directories. So within the app, you can set up a components directory where you have your map components.tsx, and then for your coordinates, when you save it out, you can put it within pages/API and then put the coordinates name. And this is the structure that we have set up. So next, similar to the backend, there are going to be some imports here. So you can go ahead and import the things that you see here. Now, I am using Leaflet, like I mentioned. We have some of the regular suspects that we're going to be used to destructuring from React. But the one thing I wanted to note with Leaflet is when I first set this up and I was trying this out with a Next.js, is I did have an issue with this particular icon here. So I found a fix to actually put in that marker, because the way that Next.js wants to load images didn't play nice with the implementation of the Leaflet library. So that's what a few of these extra things that you'll see for Leaflet are. So once you have that set up, we'll set up a quick interface for the marker data, which I'll go into in just a moment. Then here I have a simple SVG for our loader. So you could use a loader library if you want. I just wanted to quickly get something up and running. So I just got a simple SVG loader for when it queries back and forth. So I could say, what is that famous building in Toronto? It's this loader here. So that's what this is doing here. So it's going to load once we submit the query, and then as soon as it has done its zoom and pan over, it's going to remove that loading state. So here is going to be where we have our large map component, which renders to the screen here. And this is going to be where we wrap everything that we're going to put basically with what you see on the left-hand side here. So the first thing that we're going to do is we're going to initialize a number of different variables for our state. So we're going to have our input value, we're going to have our marker data, we're going to have our loading state, so whether it's loading or whether to set it to loading. We're going to have the submitted question, which we'll store and show on screen here. Then next, what we're going to do is we're going to use a ref to declare the reference for our map, which we'll see why we need in just a moment. So our zoom handler, this is a large part of our logic. Now, what we're going to be doing here is this is going to be where we fly across to our marker, but we have a lot of checks just to make sure that it's in a proper state to go ahead and perform that action. So here we specify that there is that animation as well as the duration of the animation. All right, so next we're going to be setting up a use effect that is looking for whenever the marker data changes. So whenever we get new coordinates, it's going to perform that fly to marker function. Then next we're going to be handling our submit. So we're going to set our loading state to true, wrap everything in a try catch. We're going to set our submitted question to be available here for when we want to render it. We're going to clear the input. And then we're going to make the fetch request with what is within our input. And finally, once we have the data back, we're going to set the marker data there. And then we're just going to log out any errors if they exist. And then in the home stretch here, we're just going to render out our JSX. So we're going to set our loader. We're going to have conditional rendering for our title. So for when we get that title, we're just going to display it within the top right-hand corner here. Then from there, we're going to set an initial state for our map container. So I have it set for the Toronto coordinates here. And then from there, we're going to have the tile for our open street map here with Leaflet. And then we're going to be conditionally rendering our markers here. So as our marker data comes in, that's going to be how we render them out there. And then we also have the zoom handler. So this is how it gets bound within our JSX to perform that zoom logic to hop in and between the different markers. So then finally our input here. So we have our submitted question, and you will see I do have a number of z-index items that are being pulled to the front here. That is largely because there is z-index within the Leaflet library. So I'm just being a little bit more opinionated to pull those things right to the front to have them on top of Leaflet. So we have our input, we have our submitted question like you see here. So it's simply listening for the enter key as well as the submit button. And then from there, that's pretty much it. So we're going to export our map component to be able to use it within our page. And then from there, you'll have a working GPT-4 app. So we did this all within less than 200 lines of code with comments. So it's pretty simple to set this type of thing up. So hopefully this gets the gears spinning on how you can use something like GPT-4 or any LLMs for applications that aren't just chat-based. You can use it for a lot of different things. So in future videos, I'm going to be covering a whole host of other different ways that you can leverage LLMs to interact with UIs like this. So if you found this video useful, please like, comment, share, and subscribe. Consider becoming a Patreon subscriber as well. I'd greatly appreciate it. Otherwise, until the next one.